Welcome you all in the series of laws of chemical combinations. In one of the previous video, we discussed about the law of conservation of matter, that is law of conservation of mass. In the current lecture, we'll discuss about the law of constant composition, that is law of constant definite composition, which is also known as law of constant proportion or definite proportion. This law is also known as the Proust law. Okay, so you got an idea. This law was stated by the French chemist Joseph Proust in 1798. This law was stated. What is the statement of this law? Here I have kept. Okay, I'll tell you. This law states that any pure compound always consists of same elements in definite proportion by mass, irrespective of its method of preparation or source. This is the statement of law. Here it is written. What is its meaning? Any pure compound. Okay, here I'll take the example of pure water, universal solvent, pure water. So pure water, that pure water always consists of which two elements? Hydrogen and oxygen. Law is simple. What law means, that also we know. Here we have to correlate that. Whatever we know, it was stated in the law of constant proportion or constant composition, that we should link only. Okay, so pure water, it always consists of hydrogen and oxygen, we know. The main thing is that irrespective of source, it may be a rainwater, it may be river water, it may be mineral water, mineral bottle which we purchase, okay, or filter water, and it may be from India or any other country, Australia, America, China, Japan, or from anywhere. If it is pure water, so pure water always consists of hydrogen and oxygen, and by mass, the ratio of the mass ratio of hydrogen to oxygen is fixed. Here we know hydrogen atomic weight 1, so 2 hydrogen correspond to the 2, and oxygen atomic weight 16, so here 1 oxygen correspond to the weight 16. 2 as to 16 is nothing but the 1 as to 8. So in pure water, always hydrogen to oxygen, the mass ratio is 1 as to 8. In 1 as to 8 mass ratio, hydrogen and oxygen are present. We can take the many different examples. Okay, say for example, I hope you understood, any pure compound always consists of same elements and mass ratio is fixed one. So let's have an example of carbon dioxide. In carbon dioxide, what is its formula? CO2. So carbon dioxide, no need to say, always consists of carbon and oxygen. Either the carbon dioxide is get produced by the respiration, okay, of the living beings, or by the combustion of fuels, or combustion of fuels in industries, or combustion of fuels in vehicles. So carbon dioxide, wherever it is get produced, or it may be a part of that greenhouse gases. So carbon dioxide always consists of carbon and oxygen, and mass ratio of carbon to oxygen is fixed. How much it is? Let's try to calculate. Carbon atomic mass, how much? 12, and oxygen atomic mass 16. So 2 oxygen we have, 16 plus 16, 32. So it's a 12 as to 32, nothing but this 6 as to 16, 3 as to 8. So by mass, carbon to oxygen mass ratio is 3 as to 8 in carbon dioxide, and that ratio is the fixed one. Always it is fixed. Okay. So as a homework, you try to calculate. Homework I am keeping. Calculate mass ratio of elements in, so here compounds I am writing 1, 2, 3, 4, 5. NO, what is the mass ratio of nitrogen to oxygen? NO2, okay. NH3, then which should I give? CH4, okay, and let's have a CCl4. Okay, for example, nitrogen, atomic mass of nitrogen is 7, atomic number 14, and oxygen atomic mass is 16. So it's a 14 as to 16, 7 as to 8. correct? So in this way you try to determine the mass ratio. It means what? Nitrogen monoxide always consists of nitrogen and oxygen, and by mass the ratio of nitrogen to oxygen is 7:8. Okay, this I told about the statement and examples. Homework is also given. Now let's listen the exceptions. What are the exceptions for the law of this constant composition? Exceptions are the practically when the new chemical compound is get synthesized, okay, different methods are there to obtain chromatographic methods, and some other methods are there. I have kept one video in organic chemistry part, okay. So that also you may refer. So the we got many times we got the mixture, okay. Instead of pure compound we got the different, say for example we are getting the iron oxide, but that iron oxide may consist of FeO, Fe2O3, Fe3O4. Suppose Fe2O3 is the major product, but some amount of the fractional amount of the other oxides of the iron, they may also be present there. So can we apply, suppose if I give you sample of iron oxide and mostly it is Fe2O3, but it also consists of FeO and Fe3O4. So can we apply, is the proportion of iron to oxygen is fixed in that case? Are you understanding? If I am talking about the Fe2O3 only, so then I can say Fe2O3 pure if we have. So iron to oxygen ratio is fixed. Okay, just we have seen. But practically we got the mixtures, we have to separate them, and we can't 100% perfectly separation is not feasible, not possible. Okay, so that's why uh, the compound with the varying composition of elements, that is exception. Are you understanding? First you may note exception. The first exception for this law is compounds or mixture of compounds with varying proportion or varying composition of elements. I gave the example of iron oxide. Suppose if we synthesize, okay, even though suppose Fe2O3 is major product, but it may consist of FeO, Fe3O4, okay. So the ratio of iron to oxygen in that mixture may not be identical, or it is not identical. Another example is of natural polymers. For the natural polymers, we can't apply the law of constant composition. Less cotton, silk, jute, okay, for them we can't apply because it's a polymeric one, and the units may be little short, little longer one, okay. One molecule may consist of 5,000 subunits, one may consist of 6,000 subunits, okay. And sometime some derivatives may also be there, okay. So because of that length, natural polymers, we can't apply the law of constant composition for them also, correct. And if the compound is made by the elements with the varying isotopic composition, if compound is formed by the elements, of course compound is formed by the elements, but if it is formed with the elements with varying isotopic composition, so in that case also we can't apply, okay. For example, here there is a one student A, another student B. Student A brings the combustion of carbon and produces carbon dioxide. Student B also brings the combustion of carbon and here produces carbon dioxide. So one may say that carbon dioxide carbon to oxygen proportion is fixed, but whatever the carbon student 1 took, so the proportion of C12, C13, C14, whatever the proportion that student A have, student B suppose not having the same proportion. Generally it is same, but I want to tell you the exception. Suppose here the C12, C13, C14 isotopes you know. So here suppose C12, first student use the C12 as a major reactant, another one use the C13 as a major reactant. So will there be proportion of carbon to oxygen be fixed in this case? Because for the first student here there is a C12 is major, for the second student C13, okay, atomic mass C13, that is major one. So that is also one exception, okay. So here I told some major things. Okay, any pure compound always consists of same elements in definite proportion by mass, irrespective of its method of preparation or source. Okay, thank you for watching.